What if I told you that over 2,000 years ago, someone built a computer? Not a metaphor, not a primitive tool, not a sundial. A computer. A machine with over 30 hand-cut bronze gears, interlocking at tolerances that modern engineers, armed with CNC machines and laser measuring tools, describe as almost impossible to replicate by hand. A machine that could predict solar eclipses, track 5 planets simultaneously, calculate the position of the moon to account for its uneven orbit, display a 4-year athletic calendar, including the Olympic Games. And then it disappeared. For 2,000 years, nothing like it existed anywhere on Earth. Nothing. So the question I want you to sit with, right now, before we go any further, is this. What else did they know, and why don't we? Stay with me, because what we're about to unpack changes everything you thought you knew about ancient history. It's the spring of 1900. A group of Greek sponge divers, blown off course by a storm near the tiny island of Antikythera, a rocky speck between Crete and mainland Greece, decide to dive while they wait out the weather. What they find on the seafloor changes history. An ancient Roman shipwreck, preserved for 2 millennia under 60 meters of cold, dark water. The cargo, statues, jewelry, glassware, coins, extraordinary artifacts from the 1st century BC. But among all of it, one object almost gets ignored. A corroded, barnacle-covered lump of bronze and wood, about the size of a shoebox, cracked into 3 main fragments, so degraded that when it's hauled up to the surface, no one is quite sure what it is. It gets sent to the National Archaeological Museum in Athens. Archaeologists note it, log it, and then mostly set it aside. For 2 years, it sits on a shelf. Then, in 1902, archaeologist Valerio Stais is studying the fragments when he notices something that stops him cold. Gears. Inside the rock-hard corrosion, gears, interlocking, deliberate, engineered gears. He announces that the device appears to be some kind of astronomical clock, the scientific community's response. Mockery. The consensus, it must be a medieval artifact that fell into the ancient shipwreck somehow, because what Stais was describing was impossible. Ancient Greeks did not have this technology. Ancient Greeks could not have built this. The device was quietly shelved again. For decades. And this is where the story gets uncomfortable, because the scientific establishment didn't just disagree, they dismissed, they buried, they moved on. And in doing so, they ensured that one of the most significant technological discoveries in human history would sit in a drawer, misunderstood, for the better part of a century. Ask yourself, how many other impossible things are sitting in drawers right now? It's not until the 1970s that British science historian Derek de Solla Price gets serious access to the fragments. He uses gamma-ray imaging, cutting edge for the time, and publishes a landmark paper in 1974 titled Gears from the Greeks. His conclusion is staggering. This device, he writes, is so far beyond anything else we know from the ancient world that it represents a singular leap. A technology with no known predecessor, and crucially, no known successor for over 1,000 years. Let that sink in. But even Price's analysis turned out to be only scratching the surface. In 2006, a multinational research team called the Antikythera Mechanism research project used cutting-edge polynomial texture mapping and high-resolution X-ray tomography, the same technology used to scan mummies, to peer inside the fragments without disturbing them. What they found was beyond anything anyone had imagined. Let me break down what this machine actually does, because this is where your jaw drops. Before we move on, if you're enjoying this, a quick subscribe really helps the channel out. Let's get back to it. The front face. The main front dial shows the Greek zodiac and the Egyptian calendar simultaneously. A golden sphere representing the sun moves across the zodiac to show the time of year. A second pointer tracks the moon, not just its position, but its phase, using a small rotating black and gold ball that mimics the waxing and waning of the moon as you watch. But here's where it gets extraordinary. The ancient Greeks knew somehow that the moon's orbit is not a perfect circle. The moon moves faster when it's closer to Earth, slower when it's farther away. This is called the lunar anomaly, and it's a phenomenon that Johannes Kepler would not mathematically describe until 1609 AD. The Antikythera Mechanism accounts for it anyway. Using a pin-and-slot mechanism, an eccentric gear system of breathtaking ingenuity, the device physically models the moon's variable speed. The pin sits off-center in a slot, and as the gears turn, the slot forces the pin to speed up and slow down in a perfect mechanical analog of the moon's actual behavior in the sky. This is not primitive, this is not approximation, this is exact. The back face. Now flip the device over. The back is dominated by two large spiral dials, and these are arguably even more impressive. The upper spiral tracks the Metonic cycle, a 19-year period after which the phases of the moon repeat on the same days of the solar year. It was used to reconcile lunar and solar calendars, a problem that has troubled civilizations from Babylon to Rome. The dial is divided into 235 months, because 19 solar years equals exactly 235 lunar months. The mechanism tracks this automatically. Nested inside the Metonic dial is the Kepler cycle, a 76-year refinement of the Metonic cycle, even more precise. The lower back spiral, that's the Saros cycle, a 223-month period used to predict eclipses, and nested inside that, the Exeligmos cycle, a triple Saros of 669 months, which tells you not just when an eclipse will occur, but what time of day you'll be able to see it from your location on Earth. And we haven't even gotten to the planets. Recent research, published as late as 2021 by University College London Professor Tony Freeth and his team, decoded a section of the mechanism that had never been fully understood. The front of the device, they concluded, also modeled the motion of all 5 planets known to the ancient Greeks: Mercury, Venus, Mars, Jupiter, and Saturn. Each planet on its own gear train. Each gear train calculated to replicate that planet's synodic period, the time it takes for the planet to return to the same position relative to the Sun as seen from Earth. Mercury 116 days, Venus 584 days, Mars 779 days, Jupiter 398 days, Saturn 378 days. All simultaneously, all mechanically, all in a box you could hold in 2 hands. Tell me again that ancient people were primitive. Here's what makes engineers lose sleep over this device. The Antikythera Mechanism contains at least 37 gears. Some researchers believe the complete original had closer to 70. The teeth on these gears are cut to a precision that, when measured with modern instruments, reveals tolerances of fractions of a millimeter. By hand in bronze, over 2,000 years ago. Modern horologists, the people who make fine mechanical watches, people who have spent their lives understanding precision gear work, have examined replicas and reconstructions of this device and come back with the same verdict, over and over. This is extraordinarily difficult to make today, with our tools. In 2021, the UCL team built a working model. They used computer modeling, modern machining equipment, and a team of expert engineers. The project took years. And even then, fitting all the required gears into the space the original occupied remains, in their own words, a significant challenge. The original maker or makers did this with hand tools, with bow drills and gravers and files made of iron, with no blueprints, no computer models, no precision lathes. And they got it right. The gear ratios in the mechanism are in many cases accurate to within a fraction of a percent compared to modern astronomical calculations. The Metonic cycle gear has 235 teeth, not 234, not 236, 235, because that's how many lunar months are in 19 solar years, and whoever built this knew that. The device was also inscribed extensively. Over 3,500 characters of ancient Greek text have been identified on the mechanism's plates, functioning as a kind of operating manual. The text describes the dials, explains what they represent, and according to recent analysis, may even specify that the device models a heliocentric understanding of the planetary system, where the planets orbit the Sun, not the Earth. Copernicus proposed heliocentrism in 1543 AD. The inscription on the Antikythera Mechanism is from approximately 100 BC. I'm going to say that again. The inscription may reflect heliocentric knowledge, roughly 1,600 years before Copernicus. Either someone in ancient Greece figured out the structure of the solar system, and then the knowledge was lost, or we have been severely, catastrophically wrong about what ancient people understood. Both of those options should terrify you. Now we have to ask the uncomfortable question. Nobody builds a device like this the first time they try. You don't go from counting on your fingers to constructing a 37-gear astronomical computer in one generation. The sophistication of the Antikythera Mechanism implies generations of prior knowledge, centuries of astronomical observation, a tradition of precision metalworking, a theoretical framework sophisticated enough to translate celestial motion into mechanical movement. So where is all of that? The honest answer is we don't know, and that's the problem. The most likely origin, according to most researchers, is the island of Rhodes, specifically the school of the astronomer Hipparchus, who lived around 190 to 120 BC. Hipparchus is credited with discovering the precession of the equinoxes, developing the first trigonometric tables, and constructing one of the most sophisticated models of lunar motion in the ancient world. Some of the cycle lengths encoded in the Antikythera mechanism match his calculations almost exactly. But Hipparchus left no devices, no mechanisms, not even descriptions of mechanisms. His work survives only in fragments quoted by later writers. Which raises a question that historians treat as awkward and uncomfortable. What if the Antikythera mechanism wasn't unique? What if there were others? What if this level of mechanical sophistication was, in certain circles, in certain places, normal? Consider the Library of Alexandria. At its height, around the 3rd and 2nd centuries BC, right when this device was likely made, the library contained an estimated 400,000 to 700,000 scrolls. It was the repository of essentially all human knowledge in the ancient world: mathematics, astronomy, mechanics, philosophy, medicine. It burned multiple times, and each time it burned, knowledge died. We know from ancient writers that engineers in Alexandria were building extraordinary machines: steam-powered devices, automated theaters, programmable music boxes. Hero of Alexandria described a programmable cart driven by a falling weight that could be made to follow a preset path by tying ropes around its axle in specific configurations. It is unmistakably a program stored on a physical medium. These descriptions survived, the machines did not. What if the Antikythera mechanism survived only because it happened to be on a ship that sank in the right location, in cold water, on a rocky bottom that preserved it just well enough? What if 100 others like it rotted in libraries, burned in fires, were melted down for their bronze during harder times? We talk about the ancient world as if we have a complete picture. We don't. We have fragments. We have ruins. We have a tiny, statistically insignificant sample of what once existed, and from that sample, we've constructed a narrative of gradual, linear human progress that the Antikythera mechanism shatters completely. The official story of history says, primitive past, gradual improvement, modern present. The Antikythera mechanism says, not so fast. Here is perhaps the most disturbing fact in this entire story. After the Antikythera mechanism, the next mechanical clock of comparable complexity does not appear until 14th century Europe, specifically the astronomical clock of Giovanni da Dondi, built around 1364 AD. That is a gap of approximately 1,400 years. 1,400 years in which the wheel was not lost, writing was not lost, astronomy was not lost, but this level of mechanical sophistication simply vanished. No progression, no improvement, no primitive versions of the Antikythera mechanism from the 5th century, or the 8th, or the 10th, just nothing. And then, suddenly in medieval Europe, complex mechanical clocks begin to appear. Why? Historians have answers: the fall of Rome, the loss of the Library of Alexandria, the fragmentation of the ancient world's trade networks that allowed specialized knowledge to circulate, the economic collapse that meant there were no longer wealthy patrons to fund the kind of artisanal precision work the mechanism required. These are reasonable answers. But they don't quite sit right, because they explain how knowledge could be disrupted. They don't explain how it could be so completely erased that not one workshop, not one tradition, not one family of craftsmen maintained any version of this for 14 centuries. And here's what keeps researchers up at night. The Antikythera mechanism was not described in any ancient text that has survived. No one wrote about it. No philosopher mentions it in their letters. No historian records seeing a device like it. No inventory lists it. For all practical purposes, we found the device before we found any written evidence that it existed. Which means, if it had sunk a little deeper, if the water had been a little warmer, if the divers in 1900 had chosen a different spot to shelter from the storm, we would never have known. We would have continued believing the story, the comfortable, linear story of primitive ancients and modern moderns, the story that says we are the pinnacle of human development, the story that makes us feel safe and special and unprecedented. That story would have remained intact. What else is still intact that shouldn't be? Let me take you somewhere uncomfortable. The Antikythera mechanism is not an isolated anomaly. It is the most dramatic example of a pattern. A consistent, recurring pattern in the archaeological record of ancient knowledge that shouldn't exist according to the story we've been told. Consider the Baghdad battery. Discovered in 1938 near the ancient city of Ctesiphon in Iraq, the device consists of a clay jar, a copper cylinder, and an iron rod. If filled with an acidic liquid, vinegar, lemon juice, grape juice, it generates an electric current. It dates to somewhere between 250 BC and 640 AD. We don't know what it was used for. We don't know if the ancients understood what it was doing, but it works. Consider the dendrolite reliefs, carvings in an Egyptian temple at Dendra, dating to around 50 BC, which some electrical engineers have argued depict what looks startlingly like a Crookes tube, an early form of electric light bulb, the kind Tesla and Edison would develop in the late 1800s. Mainstream archaeology says this is a misreading of symbolic religious imagery. Maybe it is. Or maybe the ancients were experimenting with phenomena we assume they couldn't have discovered. Consider Roman concrete. Modern engineers have studied ancient Roman harbors and found that their concrete, mixed with seawater and volcanic ash, is stronger today than it was when it was first poured. It self-heals. It gets harder over time. Our modern concrete deteriorates. We cannot, to this day, fully replicate what Roman engineers built 2,000 years ago. Consider Göbekli Tepe, a massive stone complex in Turkey, built approximately 12,000 years ago, predating the pyramids by 7,000 years and, according to everything we thought we knew, predating civilization itself. Whoever built it had not yet invented pottery. They had not yet developed agriculture. They were hunter-gatherers. And yet they organized thousands of people to transport and erect 10-ton stone pillars, carve them with sophisticated imagery, and arrange them in precise astronomical alignments. Hunter-gatherers. None of these things individually overthrow history, but together, alongside the Antikythera Mechanism, they form a picture that the standard narrative struggles to accommodate. A picture that says, human intelligence has been roughly constant for at least 50,000 years. Brilliant people have existed in every era, and brilliant people, given time and resources and incentive, figure things out. They figured out the moon's anomaly. They figured out eclipse cycles. They figured out, or some of them figured out, that the Earth goes around the sun. And then something happened. The knowledge fragmented. It was lost, or hidden, or destroyed, or simply not passed on. And we built a new story. A story in which we are the smartest humans who ever lived. A story in which the past is primitive and the present is the pinnacle. The Antikythera Mechanism, sitting in a museum in Athens, calls that story a lie. Here's what I want you to take away from this. I'm not telling you that ancient aliens built the Antikythera Mechanism. I'm not telling you that there was a lost supercivilization with electricity and spaceships. I don't believe that, and the evidence doesn't support it. What I am telling you is something far more unsettling. I'm telling you that the official story, the one we learned in school, the one that says human progress is linear, that ancient people were fundamentally more primitive than us, that we have a reliable and complete picture of the ancient world, is wrong. Not wrong at the edges, wrong at the center. The Antikythera Mechanism proves that there were people 2,000 years ago whose understanding of astronomy, mathematics, and precision engineering matched or surpassed what Europe could produce 1,400 years later. It proves that knowledge can be lost, completely, without a trace. It proves that what we have found is not representative of what once existed. And it raises a question that mainstream history does not have a good answer for. If this one device, this one shoebox-sized lump of corroded bronze, has rewritten our understanding of ancient Greek technology, how many other lumps are still on the ocean floor? How many scrolls describing impossible machines burned in Alexandria? How many traditions of ancient knowledge were wiped out not by time, but by conquest, by fire, by deliberate erasure? We are not the first intelligent people to walk this earth. We are not the first to look up at the sky and ask how it works. We are not the first to try to capture the answer in metal and gears. We are just the first to be arrogant enough to assume we were. The Antikythera Mechanism is currently on display at the National Archaeological Museum in Athens, Greece. If you ever get the chance to stand in front of it, I mean really stand in front of it, knowing what it is and what it does, do it. Because it's one thing to watch a video about it. It's another to stand 2 feet away from 2,000 years of history and realize that the person who built it was just as smart as you, probably smarter, definitely more patient. And that they built something so far ahead of their time that we, with all our satellites and computers and centuries of accumulated science, are still arguing about exactly how it worked. That person had a name, they had a workshop, they had students probably, they went home at night and thought about gears. And then everything they knew disappeared. Until a storm blew a group of divers off course near a small Greek island. And a lump of corroded bronze fell into the hands of someone who knew what to look for. History is not a straight line. It never was. If this video made you see the ancient world differently, if it cracked something open in the way you think about human knowledge and what we've lost and what we might still be missing, subscribe and share it with someone who needs to see it. Drop in the comments, what other impossible ancient technology do you want me to investigate next? Because we are just getting started. I'll see you in the next one.